tell if something's a function or not by just looking at the equation? Well, we looked at the first case. You could look at an ordered pair or a table and apply what we did to see if it's a function or not. Or there's another way you could do this. It's called the vertical line test. But you have to be given a graph to do the vertical line test. As you can see here, I graphed out the balance equation, which we worked through in the beginning of the video. As you can see, here's the y-intercept at 2000 where I invested my money in, and this is the 5 months after where all my money was gone. So this would be our x-intercept. And I want to know if it's a function or not by just looking at the graph. So the vertical line test, it might sound like a hard thing to do, but it's fairly simple. What you do is you graph your function, then you apply vertical lines to it throughout different regions of the graph, and then if it hits the line more than once, it's not a function. If it hits just once, that's fine. So let's go ahead and try the vertical line test. Apply the vertical line test to our graph here. So I'm just going to take this area. If I drop down a vertical line here, I see that it hit at one point on my graph. Let's look at another region. Let's look to the right of that. I'm going to apply a vertical line out here. Again, I could just see that it hit my graph just once. And let's look at it over here maybe. Also hitting once. So we could conclude that throughout anywhere that I draw these vertical lines on my graph, they're only going to hit my function or line only at one given point. So by that we could conclude that this line here that we've graphed is a function, because when we applied the vertical line test to it, it only hit our graph only at one spot. Okay, still working with vertical lines. We just looked at the line case. Now here's something that looks a lot different. If you were curious to see what the equation of this looks like, of this graph generated here, it's a hyperbola that's opening like this. It's hitting the x-axis, so the y would get the negative. But that's really not the point of this video. If you were curious about the equation, it's right here. Now, we're going to apply the vertical line test to this guy, and we know if it hits, when we draw a vertical line, if it hits the graph once, we know it's a function. If it hits more than once, we know that it's not a function. So let's investigate to see what's happening here. I'm going to start in this region right here. So if I drop down a vertical line, I notice that it hits right here, and it also hits here. It hits my graph at two different locations, so we already know that it's not a function. But I'm just going to draw a couple more vertical lines down. It's symmetrical, so we know the same thing would happen here, but I just want to show that. So here we also notice that the vertical line intersects our graph at this point, and also at this point here. So we know that this is not a function, as I mentioned earlier. But really, why it's not a function? Let's look at that. So this vertical line that I drew right here, let's say that this x value here was, let's just say x1. If we trace up to see where it has a y value, it hits the graph right here. So this would be the y value corresponding to x1. But if we trace back in the other direction, we see that it has another y value corresponding to it. So I'm going to go ahead and call this y1, and I'm going to call this y2. So if we were to make an ordered pair out of what I've made here, so at x1 we get a y value of y1, and at x1 we also get a different value, which is x2. Oh, I'm sorry, I meant to say y2. So, by the function definition, every input has exactly one output affiliated with it. So at x1, I'm getting a value of y1, and at x1, I'm getting a different output, which is y2. So that's really why, when we apply the vertical line test, when it hits our graph more than once, we're really saying that you're getting two outputs for that one input, and that's really why it's not a function.